let's draw the shear force and bending moment diagram for this frame. And we have a rigid support, so we're going to have a horizontal reaction counteracting that 1 kilonewton load by horizontal equilibrium, and by vertical equilibrium of forces we have a 2 kilonewton reaction counteracting the external load. And because it's a fixed support, we also have a moment reaction to prevent rotation. So if we take a sum of moments about this support with our usual convention, then we have the moment m minus 1 kilonewton by the moment arm, and then minus 2 kilonewtons by the moment arm, which both cause a clockwise moment. So therefore the moment reaction is 4 kilonewton meters. And now let's first draw in our shear force diagram. And I'll remind you of the convention that we use when we cut the beam and the column. So I'll draw those in quickly. And we rotate this positive sign convention for the beam anti-clockwise to get our positive sign convention for the column. So if we cut the beam from right to left, we use this convention. And we can see that the shear force is 0 up to the point load. And if we again cut the beam from right to left, we can see that the shear force is constant at 2 kilonewtons by a vertical equilibrium of forces. So that's our shear force diagram, constant at 2 kilonewtons for the beam. Now if we cut the column from bottom to top, we use this sign convention on the top, and we can see that by horizontal equilibrium of forces, the shear force is constant at 1 kilonewton in the column. So this here is our shear force diagram for the frame, where we draw the positive diagram on the top of the beam and to the left of the column. And now let's draw in our bending moment diagram. Well, without taking moment equilibrium to find the bending moment in the column, we know that the bending moment at the fixed support is equal to the moment reaction of 4 kilonewton meters. And we know that the bending moment on the right of the point load is 0, and to the left of the point load is simply going to be the point load by the moment arm. That will be 2 kilonewtons by 1 meter, or 2 kilonewton meters. And because there's no externally applied moment at the joint, the bending moment in the beam is going to be the same as that in the column. And there's no load acting on the column, so that's going to vary linearly to 4 kilonewton meters. So here we normally write the magnitudes, but this indicates that the beam is hogging and the column is in tension on the left. So what the bending moments will look like at the joint: for the beam it looks something like this, and for the column it looks something like this. So these will counteract each other such that the net bending moment at the joint is 0. Please subscribe, like and comment to help me reach more students.